Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, everyone. Thank you, Mr. Chairman, for the introduction. Okay, so today I would like to share, actually it's not telling you what we really found out, but it's just a sharing session. This is the use of AWE Gen for projecting future extreme rainfall in Malaysia. So the work is mainly done by my PhD student who has just gone through her Viva. Okay, I had been working a lot on extreme rainfall, both for my PhD and for my research. So let's just look at what IPCC says is the definition of extreme event. Okay, an extreme or weather or climate event is generally defined as the occurrence of a value of a weather or climate variable above or below a certain threshold. Okay, and if we were to plot it, it will be somewhere towards the tail of the range of observed values. Okay, and I believe those of us who work with the extreme event, we are very familiar with that. Okay, so some climate extremes may be the result of an accumulation of weather and climate events, meaning that individually that event is not in itself an extreme event, but due to an accumulation of several events, it becomes an extreme event. Okay, and on the other hand, we also have weather or climate events. Even if not extreme in the statistical sense, it can lead to extreme conditions or impacts by crossing a critical threshold in a social, ecological, or physical system, or by occurring simultaneously with other events. So for this one, we have sometimes events, let's say a typhoon, which is just a minor typhoon, but due to its occurrence within a certain time, it becomes a critical threshold in that within that social place where it is happening. Okay. And in terms of precipitation, because I will be focusing on precipitation only, there is actually a very hazy definition of what is an extreme precipitation, because we know that climate is very diverse across the globe. So in general, approaches that is used to define what is extreme or heavy precipitation, the first one is using percentiles. Okay, this is a relative threshold, and typically the 95th percentile or above is used for defining an extreme precipitation. For absolute thresholds, this will be used according to region or country. So let's say in the United States, they use 50.8 mm as an extreme precipitation. In China, they use 100 mm per day. Okay? And studies on extreme precipitation are abundant in the literature, and globally there have been increases in the number of heavy precipitation. Okay. These are just some of the example of studies that has been done, okay, by Trenberg, Funkel. Which one is the pointer? Okay, so these are just some of the studies that are done on extreme precipitation. Okay, let's just look at some of the studies that had been done in Malaysia. The first one is Tanggang et al. In 2006, and his result was corroborated by Shahrudin in 2005, which says that there is a high warming rate, particularly in larger cities, due to the effect of urban heat island. Okay, so therefore there is a direct influence on the intensity of rainfalls in certain areas. Okay, and Wong in 2009 discovered no significant trend in rainfall's partial variability in Peninsular Malaysia. Zain et al. In 2010 work on trend in extreme event between the years 71 to 2005. They used 8 indices on daily rainfall data and increasing trend in only 2 out of the 10 stations that they work on. Okay? And then again in 2012, there are certain recent changes in stream rainfall between 75 to 2004, significant changes detected in the early 90s, okay? Especially in urban areas. Suhaila and Jermaine, 2012, high intensity rainfall observed mainly in the East Coast, okay? And then Rao et al. In 2014 analyzed 3 decades of monthly run off from 13 rivers, but he found no significant changes. Okay? So why I'm giving this is because we also work on the event of extreme rainfall in Malaysia. Okay, I will show that later. And then due to the changes in extreme rainfall, we see that projection of extreme events are being done globally everywhere. In the 4th assessment report by IPCC, it was concluded that it was very likely heavy precipitation events would increase over most areas of the globe. Okay? In the late 20th and 21st century, projected responses of extreme precipitation to future emissions show increased precipitation rates and decreases in return period in most regions, higher latitudes and tropics, and in some regions in the mid-latitudes. And again, there is abundance of literature looking at the projection of extreme rainfall. Okay? So the need to project extreme event has stimulated the development of regionalization or downscaling techniques. So next we will look at what is downscaling. Okay? Now, downscaling is a method that derives local to regional scale information from larger scale models or data analysis. And 2 main methods are available, the dynamical and the empirical or statistical methods. Okay? Now, I will be looking at the statistical method, which develops statistical relationships that link large-scale atmospheric variables with local or regional climate variables, and this include weather generators. Now, the quality of the downscale product depends on the quality of the driving model. A lot of factors come into play when we work on downscaling and projection into the future, the climate models, the place where the work is being done, and so on and so forth. Okay? So a lot of people had worked on statistical downscaling, and it has been demonstrated that there is a very good potential of using statistical downscaling, and these are some of the works that are done globally. And weather generators has been the basis for a number of recently developed user tools that can be used to assess changes in extreme event. Okay? Okay, now a little bit about studies that are done in Malaysia. Just now we look at looking on the extreme events in Malaysia. These are some studies done on statistical downscaling in Malaysia. Okay, so if you see that there are not much studies being done, that is what we can find in the literature. Maybe there are others that are not in the literature. Okay, and then if we are looking at projection of extreme event, again there is none yet that has been done in Malaysia, as far as we know. Okay, so the discussion, the main discussion of my presentation today will be firstly to look at trend of extreme rainfall events in Peninsular Malaysia, and we are now working on hourly data. Past research use daily data, and then I will also discuss a little bit about the use of AWE-GEN to project future extreme precipitation in Peninsular Malaysia, so we can see what is going to happen in future. Okay, so first of all is the trend analysis of hourly data over Peninsular Malaysia. Okay, so what we will be using, or we had used, is hourly rainfall data, and the data was obtained from 1975 to 2010 out of 20 stations. 8 seasonal extreme rainfall indices are used, and we divide the seasons in Malaysia into the northeast monsoon, southwest monsoon, and 2 inter-monsoon seasons. Okay, so all these are based on past studies that have been done. Okay, so just a little bit of precaution about the output of our research, and maybe a little bit that might affect the result of the study is that since we are looking at hourly rainfall data and we need a long series of data. So the stations that could be used for this study are quite limited, because if you work with daily or hourly data, you will know that a lot of stations have missing data. This is one of the biggest problems for us working with empirical data, okay, empirical work. So most of the stations you will see that are located on the West Coast, because this is where you get very good data. On the East Coast, there are stations, but a lot of the other stations, the data is missing. And when we talk about missing data, it can be years of missing data. So, you know, we could interpolate and all that, but we are not happy about it, so we leave it out. So these are the indices that I used in this study. Okay, so this follows what had been done by Sen Roy. These are the tests that were used. We did an autocorrelation using Durbin-Watson, a trend test. Okay, so use two types of trend tests, the parametric and non-parametric, and bridging, and then field significant test. Okay, so this is some of the results. So I will just show you the hourly maximum index that was obtained from the study. So you can see that for all the seasons and the inter-monsoon season, mostly the higher values are on the West Coast when it comes to hourly data, hourly extreme data. Okay, so the hourly max recorded a high value in all seasons on the western region. So short extreme intense rainfall hourly max was observed mainly at stations located on the West Coast. So if we are looking at hourly rainfall data, it is more on the West Coast. So significant trends of extreme rainfall indices, we use circle to indicate significant extreme rainfall indices. The circle indicates positive trend, the triangle indicate negative trends. Again, for the most of the indices, the West Coast for the Northeast monsoon have a higher trend. Okay, again during the Southwest monsoon, and during the inter-monsoon, and you can see that during the September to October is when you have very little improvement, or rather increase in trend. So for the years 1975 to 2010, 6 out of 8 extreme intensity indices has higher values of positive coefficients during the Northeast monsoon, and has the lowest during the September to October inter-monsoon season. Okay? The Western regions depicts higher indices during the March to April inter-monsoon season. Positive trend extreme rainfall is stronger during the Northeast monsoon. So still the Northeast monsoon is the season that brings most rainfall to Malaysia, Peninsular Malaysia. Short extreme intense rainfall hourly max was observed mainly at stations located on the West Coast, where the hourly maximum is recorded during the inter-monsoon season. In contrast, the extreme cumulative rainfall 24-hour max was observed at stations located on the eastern region. So we can see that there are two different rainfall experience. If we look at shorter intense rainfall, this happens mostly on the West Coast. But if we look at longer hourly, longer maximum, you will see that that happens mostly on the East Coast. Okay, so hence hourly data gives a better indication of the seasonal contribution. Okay, so that is that shows that in Malaysia there is an increasing trend of hourly maximum rainfall. Okay, and this is actually corroborated by our experience itself. We see that in Malaysia nowadays we have extreme events that are not normally experienced last time. Okay, maybe for the younger generation they don't really see this, but for the older generation we do see that there is a change in the trend of extreme rainfall. Okay, so now let's look at future projections of extreme precipitation, and what we are going to use is the AWE-GEN method. This is a weather generator. So why do we use AWE-GEN? Because this is at the moment the only statistical downscaling method that uses hourly rainfall. Okay, the other methods uses daily rainfall. Okay, so again, for the first, this is a prelim study that was done. We already had done a much more extensive study than this. But for this one, I will only show you the result for 4 stations. So we divided our 2 stations from the southern, western, eastern, and northern part of the country, and observed data from 1975 to 2005. We use hourly rainfall and hourly temperature, and actually we also have the wind speed and also humidity. Okay, but as mentioned yesterday, data, if it is sourced from MMD, which most of the data has to come from MMD, except for the hourly rainfall, we could get it from JPS or DID. The others we have to buy from MMD, and it is very, very expensive. It took up a lot of our research vote. So I have to say that we could not buy data from 75 to 2005 for all our variables. Okay, we could only do that for hourly rainfall, which is our main input into the system. For the hourly temperature, humidity, and wind speed, we only bought data for 1 year, and that is used for all the analysis. Okay, because it is too expensive. Okay. Okay, and then for the GCM, we use 5 GCM. GCM is, this one can be downloaded free. You need to pay. Okay, so in terms of the scenario, RCP 6.0 scenario is used in the analysis. Even though lately we have been told that RCP 5.5 should be a better scenario, so that could be used for further studies. And the future climate scenario based on the GCM projections for 2081 to 2100. Okay, so what is a weather generator? It is a statistical model used to generate realistic daily sequences and based on Markov chain associated with transition probabilities. Okay, and the parameters have their own probability distribution. And the parameters are estimated from statistical analysis of time series. Okay. Now, when we talk about probability distribution, in Malaysia, we already had done quite a bit on probability distribution of rainfall. Okay. Now, this is the whole scenario, or rather what is used in the AWE Gen. We use stochastic, NSRP model for intra-annual variability, and AR1 for inter-annual variability, and then factor of change was calculated, and multi-model example of the 5 GCMs are used to project the future. Okay. Now this is the Raymond-Scott rectangular pulses model, whereby we have the waiting time, and then we have the storm arrival. This is a Poisson process. The rain cells associated with these 2, lifetime of rain cell, and then the intensity of the rain cell. So mostly when we work on an SRP, namely short rectangular pulse model, we work on the intensity. So on the intensity, we could change the distribution from gamma to other distributions. My previous student had done it for other studies, and we could see that mixed exponential could also be used and might be better. But for this study, we stick with gamma distribution for the simplicity of the analysis. Okay? So these are all the parameters involved. And this is the autoregressive like 1 AR1 model. And this is the factor of change that is calculated to input into the process of simulating the climate time series. So this is the whole process. Okay, we calculate the FC, quantify uncertainties, extend it to final time scale, calculate new set of AWE Gen parameters, and then we do the simulation for the future time series. Okay, and this is the result for comparison between observed, which is the red one, and the green is the future monthly precipitation. The vertical bars denote the standard deviation of the monthly values. So if you look at the 4 stations here, there is a high variability, especially on station 2 and station 4, but station 3, which is on the east coast, is have a lower variability. So future projections of monthly extreme precipitation using the new set of studies of AWE gen parameters is used, and overall the mean amount of monthly rainfall is expected to be higher throughout all 4 stations with high variability of future monthly rainfall, except for station 3. Okay. And this is the result for the extreme projection of extreme precipitation for 1 hour. So again, the red is the observed and the green is the projected future. So if you see here, you can see that in future there is going to be a higher amount of precipitation for hourly rainfall, and for 24 hours also there is an increase. Extreme dry spell will be lower, and the return period also an increase. Sorry, a decrease in return period. And this is the result for all the 4 stations. Okay. So what we can see here, the extreme precipitation for both aggregation 1 and 24 hours seems to increase in future. The future hourly extreme for station 1 and 3 are expected to increase during the return period of 10 to 40 years. Precipitation exceeding 400 and 200 millimeters respectively. Future hourly extreme for station 2 and 4 are expected to increase during the return period 10 to 40 years, maximum 400 mm. And extreme dry spell for station projected to decrease. Okay. And in conclusion, the average in total monthly rainfall increase, a slight difference between variability, whereby the station on the East Coast shows lower variability compared to the others. And overall, the scenario of future extreme precipitation for both hourly and 24 hour is expected to increase. Okay, so that is all. Thank you for your attention.
Okay, thank you very much. Dr. Zalina, you have 10 minutes to answer more, I think, or 8 minutes. Anybody want to ask any questions? You have any ambiguities? It's too cold early in the morning.
Yes.
Okay, anybody want to ask any questions?